Welcome to the last topic in chapter 2, which is the medium components. We will look into detail of what a component, what a medium consists of. So, um, the element composition of bacteria, yeast, and fungi as percent of dry weight. So if you took bacteria, yeast, and fungi respectively, and we study the composition or the elements that they have within them, so this is the distribution. We have carbon, and you can see bacteria contains 50 to 53% carbon, yeast about 45 to 50%, and fungi varies about 40 to 63%. Hydrogen, bacteria got 7%, yeast got 7%, and none is detected in fungi. And nitrogen, we have 12 to 15% in bacteria, 7.5% to 11 in yeast, and 7 to 10% in fungi. So you see it varies. Phosphorus, sulfurs, potassium, sodium, calcium, magnesium, chloride, and just 0.5 in bacteria and none in yeast and fungi. And we have iron. So the way usually the element is arranged according to the highest, then down to the lowest one. So this is also the method that we use as ingredient in any of the food product as well. Now, usually the medium or the media component has four elements. The first one is the carbon sources, second one nitrogen sources, third one other substrates, and the fourth one is inhibitor. So if we look on the plate that they grow, bacteria will look like this, fungi like mold and yeast, and we have this Candida albicans in Cerebrate agar. Now, what are these carbon sources for? So the carbon sources is used to provide the cell with energy as well as the material with which to grow and synthesize a range of primary and secondary metabolites. So you see that is why carbon is the highest content in any element, because that is used to provide the energy. Should be appropriate to the organisms and to the economics of the process. A typical microorganism is approximately 50% of carbon. Carbon, the most significant substrate in the media. Care should be taken to ensure that carbon concentration does not become limiting. If you put too little of carbon, it will limit the overall reaction of synthesizing the microbes. Now, what are the type of carbon source that you can use? Number one, the most favorite and easiest for the microbe to consume is glucose, and this is also our body favorite energy source, glucose. Universally acceptable for growth, the most saline, supplied as powder in pure form, readily available, reliable, easily stored, and whatnot. In large scale, supplied as glucose syrup, manufactured by the hydrolysis of starch. So glucose syrup is cheaper than powdered glucose because you don't have to go to the further process to make it solidify via maybe spray dryer and so forth. The disadvantages of glucose is the possibility of organisms suffering from the cup tree effect if glucose is overly supplied in the initial stage of the growth. And this happens only in glucose syrup. So the loss of available substrates to Maillard reaction, which can occur if the glucose is sterilized with a nitrogen source present. An additional complication of transportation, storage, and handling of liquid glucose. So this only happens in glucose syrup only. So how to overcome this? Careful monitoring and control of glucose feed, sterilizing the substrate separately or by using filtration sterilization method. Remember, we have the autoclave method using heat, and we also have the filtration method that pass through the filter. The second type of energy source is sucrose. sugar of choice in research laboratories, utilized by many but not all cell lines, come in different forms and grade. It can be autoclaved, that's why it is favorable in research lab, or sterilized with nitrogen compound without the same problem as glucose. However, the disadvantage is it's subject to caramelization when over sterilized. And the third one is lactose, can be utilized by few cell types, example E. coli, and is usually only metabolized very slowly, only really useful for some commercial processes because the use of complex substrate whey, a byproduct of the dairy industry, and contains both lactose, available as liquid or as whey powder. Some fermentation media in the past typically batched in both glucose to achieve rapid growth and lactose, which was only utilized after glucose exhaustions and the slow rate of usage fuel. So they add on with both the glucose and the lactose because glucose is easily used or easily synthesized for them, but not lactose. So it has to be degraded first for them to consume. And the fourth type of energy is oil. Oil are routinely used as carbon source in bioprocess industry. Example of the oils is rapeseed, canola oil, and methyl oleate. Oils are economical and readily available, so the variation exists. Hence, the composition and the quality of oils also varied or different. Must be regularly assayed to check for variations in component content between batches. Can be used as anti-foaming agent, thus avoiding the use of non-metabolizable antifoams that can potentially interfere with downstream processing activities. Hence, if you are using this oil as your energy source, it can also act as the anti-foam in your process. Now, that done with that carbon or energy source, now we are moving into nitrogen source. The amount of nitrogen in any medium determines the amount of biomass that will be achieved. For the particular cell line, nitrogen is required for growth and synthesis of, for instance, protein and nucleic acid. And we all know that the protein and nucleic acids is the building block and is needed. So what are the type of nitrogen that you can use? You can use ammonia, like not common source used in research lab because it is highly volatile. It got handling problems and have health issues with it. So it requires special handling, storage, and breathing equipment. The advantages, it's easily or readily dissolved in medium, available, immediately available to the cell, and it's cheap. The second nitrogen source is nitrogen-based salt. For example, ammonium sulfate and ammonium chloride. Ammonium is very utilizable by many organisms, so salt is cheap and convenient methods to supply to the cell. The advantages is easy to calculate the exact amount of nitrogen being supplied. The storage of substrate is easy because it only needs a cool and dry place. Analysis of nitrogen content using simple assay and ammonia probe. Watch the combination of salt used and the order in which they are added. So an incorrect combination can lead to a batch vessel full of salt crystal. Right. Other source of nitrogen is complex nitrogen sources, and this could be yeast extract, soybean meal, and corn steep liquor. All supply a significant amount of nitrogen in addition to other essential nutrients such as carbon, vitamins, and minerals. Significant batch-to-batch variability has to be analyzed for component composition before we use them. And moving to the third medium composition, which is other substrates. So these are the elements in forms of inorganic salt. So the cell grow and function properly. And I've listed 6 here. The first one is calcium. And what is the calcium used for? To stabilize cell wall. Important if the cells form endospore. And we have magnesium. It's a cofactor for the activity of enzyme, role in membrane structure and function. And we have phosphorus, production of phospholipids, nucleic acid, and generations of energy. We've got potassium, involved in many reactions within cell. And this potassium is very much important. And well, we have sodium, absolute requirement for sodium, especially for marine species and halophiles, and sulfur for amino acid synthesis and productions of some vitamins. So um, then we have these trace elements as the other uh, substrates as well. Regarded as micronutrients, they are required in tiny amount only, and the functions associated with enzyme activity, part of the enzymes of function as catalyst. So typical trace elements of iron, copper, manganese, molybdenum, and chromium. So we have to store them carefully because the trace element solution can last many weeks, but should evidence any precipitation, the new solution should be made off. The third one is growth factors required only in tiny quantities by the cell. So often this can be manufactured by the cell itself. However, some cells do not have the ability to manufacture certain key growth factors, and they must be supplied to the cell in the medium. And these are organic compounds such as vitamins, purines, pyrimidines, and amino acid. Now moving to the last composition of the media, which is the inhibitors. Any medium formulation should be free of compounds that inhibit the cell to be cultivated. Most cell types, if overfed, first they exhibit undesirable activity, they excrete toxic byproduct or waste product, which can lead to slow growth of or product synthesis or terminations of the fermentation process. Synthetic or semi-synthetic media, known inhibitors are easily avoided. For complex media, however, there are inhibitors present that have to be removed prior to the use. So what are inhibitors? Inhibitor, a substance added to the media to suppress or prevent the growth of unwanted microorganism without affecting the organism of interest, and in particularly important in selective media. For example, antibiotics, we have to select bacteria with antibiotic resistance. Other inhibitors might include bile salt, which inhibit gram-positive bacteria, and the select gram-negative bacteria. And pH can also be an inhibitor, where a specific pH range may prevent the growth of certain microbes. Okay, that's it. That's the end of the last subtopic of chapter 2. Let's test yourself. Now, the first one, you can list all carbon sources available and explain why glucose is the favorable carbon source. And the second part, explain how nitrogen is utilized by microorganisms in culture media. The third one, choose an element and describe its role in microbial growth. And last but not least, give an example of an inhibitor that could be added to a culture medium and explain its selective effect on microbial growth. And I'm expecting the answer to be submitted to me via the author, or those who have not have yet author can PM me your answer by the end of the class today. Thank you guys. Enjoy.